The Curtiss P40 Warhawk was never supposed to win against the Zero. It was heavier, slower to climb, and turned like a freight train compared to Mitsubishi's aerodynamic masterpiece. Yet, on a sweltering morning over the Huon Gulf in 1943, one American pilot in a battered P40E would do exactly what every tactical manual said was impossible: survive an encounter with 15 Japanese fighters who had every advantage except one. They did not understand that desperation in physics could rewrite the rules of aerial combat. Before we go deeper into how this decision changed the Pacific War forever, make sure to subscribe for more history that actually happened. The morning of March 28, 1943, begins like every other at WW2 airfield on New Guinea's northern coast. First Lieutenant James Robert Thompson stands beside his P-40E Warhawk, serial number 41 to 25,188, running his hand along the fuselage where ground crews have patched bullet holes with aluminum sheeting and rivets. The aircraft reeks of hydraulic fluid and aviation gasoline. Its olive drab paint has been scoured nearly white by coral dust and tropical sun. 6 Browning M250 caliber machine guns protrude from the wings, each loaded with 235 rounds of armor-piercing and incendiary ammunition. The Allison V1710-39 engine, generating 1,150 horsepower at takeoff, ticks and pops as it cools from the morning's pre-flight engine run. Thompson is 23 years old, from a farm outside Grand Island, Nebraska. He has been in the Southwest Pacific Theater for 8 months, accumulating 287 combat hours in the P-40. His logbook records 47 combat missions: bomber escort, ground attack, combat air patrol. He has 1 confirmed kill, a Mitsubishi GE-4M Betty bomber destroyed over land January. His hands show the permanent tremor that afflicts most fighter pilots after their first 100 hours of combat. The tremor comes not from fear, but from the constant physical stress of high-G maneuvers, the vibration of 6 machine guns firing simultaneously, and the exhaustion that comes from flying a fighter that demands absolute attention every second the propeller turns. The mission briefing at 0630 hours is routine. 8 P-40s from a 7-fighter squadron will escort 12 Douglas C-47 Skitran transports carrying ammunition and medical supplies to the forward airstrip at Wau, deep in New Guinea's interior. The transport aircraft will fly at 8,000 feet through the mountain valleys. The fighters will provide high cover at 12,000 feet. Intelligence reports indicate light Japanese air activity in the area. The weatherman predicts broken clouds at 6,000 feet, scattered cumulus up to 15,000 feet. Surface winds from the... Thompson climbs into the cockpit at 0715. The cockpit is cramped, the instrument panel a constellation of gauges that must be monitored constantly. Manifold pressure, RPM, oil temperature, coolant temperature, fuel pressure, ammeter, turn and bank indicator, altimeter, airspeed indicator, artificial horizon. The P-40 is an unforgiving aircraft. Its liquid-cooled Allison engine will overheat if the pilot climbs too steeply or runs too rich a mixture. The narrow-track landing gear causes ground loops during takeoff and landing. The aircraft center of gravity shifts dramatically as ammunition is expended and fuel is burned. But it has virtues that matter in combat. It is fast in level flight and faster still in a dive. It can absorb tremendous battle damage. Its 650 caliber machine guns deliver 4,200 rounds per minute of devastating firepower when all 6 guns converge on a single point 250 yards ahead of the aircraft. At 0728 hours, Thompson starts the Allison engine. 12 cylinders arranged in a 60-degree V configuration roar to life, the 3-blade Curtiss electric constant-speed propeller turning at 2,000 revolutions per minute. He runs through the pre-takeoff checklist: fuel selector on main tank, mixture rich, propeller control full forward, oil cooler shutters open, radiator flap automatic, trim tabs neutral, elevator trim slightly nose-heavy to compensate for takeoff weight. At 0732 hours, he releases brakes and rolls down WW2's pierced steel planking runway, the P-40 accelerating through clouds of coral dust. At 85 miles per hour indicated airspeed, he eases back on the stick and the Warhawk lifts into New Guinea's brutal morning heat. The flight assembles in loose formation at 5,000 feet over Dobadura. Thompson flies as element leader, second section, with Second Lieutenant Walter Klein on his wing. The 8 P40s climb to 12,000 feet and set course northwest toward Wau, following the transport aircraft that lumber along below at 140 miles per hour. The formation crosses the coastline at Oro Bay. Below, the jungle canopy stretches unbroken to the horizon, a green hell where Japanese and Allied infantrymen wage a war of attrition in conditions that defy human endurance. At 0814 hours, everything changes. The radio erupts with urgent transmissions from coast watchers stationed on the northern slopes of the Owen Stanley Range. Japanese fighters inbound from La, bearing 315 degrees. Altitude estimated 15,000 feet. Number unknown. Flight leader Captain Raymond Malikian orders the P-40s to climb to 14,000 feet and spread out in combat formation. Thompson scans the sky, searching for the tiny glints of reflected sunlight that betray an aircraft at altitude. His throat is dry. His hands tighten on the control stick and throttle. The Allison engine labors in the thin air, manifold pressure dropping as altitude increases. At 14,000 feet, the P-40E can barely climb 500 feet per minute. Every Japanese fighter in the theater can outclimb it by a factor of 2 or 3. At 0821 hours, Thompson sees them. 15 aircraft diving out of broken clouds at 18,000 feet. The distinctive silhouettes are unmistakable. Mitsubishi A6M2 Type 0 Model 21 fighters, what American pilots call Zeros. They are arranged in 3 Shotai formations of 5 aircraft each, a tactical unit perfected by the Imperial Japanese Navy in combat over China. Each Zero is painted in dark green upper surfaces with light gray undersides. Red Hinomaru roundels mark their fuselages and wings. They are diving at over 300 miles per hour, positioning themselves above and behind the American formation. The mathematics of the engagement are brutal. 15 Japanese fighters against 8 American fighters means nearly 2-to-1 odds. But the tactical situation is worse than the numbers suggest. The Zeros hold the altitude advantage, which translates to energy advantage, the fundamental currency of air combat. They can dive, build speed, attack, and climb back to altitude using their superior power-to-weight ratio and climbing ability. The P-40s, already at near maximum altitude for effective maneuvering, cannot climb to meet them. They cannot outturn them. The A6M2 has a turning radius of approximately 500 feet at combat speeds. The P-40E's turning radius at the same speed is nearly 800 feet. In a turning fight, the Zero will position itself on the P-40's tail within 2 complete circles, bringing its 2 7.7mm machine guns and 2 20mm Type 99 cannon to bear. Captain Malikian makes the only decision that offers any chance of survival. He orders the formation to jettison belly tanks and break into the attack. 8 P-40s split into 4 two-plane elements and turn toward the diving Zeros. This is the tactic that Claire Chennault taught his Flying Tigers in China. Never try to dogfight the Zero. Use the P-40's superior speed and diving ability. Make 1 high-speed pass, fire a burst, and extend away in a dive. Never turn. Never climb. Use speed to disengage, then reposition for another diving attack. But tactics assume equal numbers or at least reasonable odds. Thompson watches as the Japanese formation splits into 3 groups. 1 Shotai of 5 Zeros continues its dive toward the sea, 47 transports below. 2 Shotai, 10 fighters, turn to engage the P-40s. The engagement begins at 0823 hours. Thompson sees a Zero diving toward his element at tremendous speed. He rolls inverted and pulls the nose down, dropping into a split-S maneuver that trades altitude for speed. The P-40 accelerates rapidly the airspeed indicator climbing past 300 miles per hour, past 350, approaching 400. The Zero follows, but at these speeds, the lightweight Japanese fighter encounters severe control problems. Its manual ailerons require tremendous strength to operate above 300 miles per hour. Its structural limitations become critical above 350. Thompson pulls out of the dive at 8,000 feet, 6 G-forces crushing him into his seat, his vision tunneling to gray as blood drains from his brain. The Zero cannot follow through the high-speed pullout. It breaks off, climbing back to altitude. But there are 14 more. At 0825 hours, Thompson's wingman Walter Klein calls out multiple bandits high and behind. Thompson looks back and up, seeing 3 Zeros diving in trail formation. He brakes hard left, pulling maximum G, the P40 shuddering at the edge of a high-speed stall. Tracers flash past his canopy, 7.7mm rounds from the lead Zero's Type 97 machine guns. He reverses right, then left again, a scissors maneuver designed to force and overshoot. The tactic works. The lead Zero flashes past, unable to match the P40's roll rate at high speed. But the second and third Zeros are still there, and now Klein radios that he has lost sight of Thompson in the melee. Thompson is alone. The engagement that began as 8 against 15 has dissolved into individual fights scattered across 20 square miles of sky. Radio discipline collapses as pilots call out targets, threats, ammunition states, and fuel levels. Thompson checks his fuel gauge. 45 minutes remaining. His ammunition counters show 1,200 rounds expended from the initial engagement. He has approximately 800 rounds remaining, 17 seconds of firing time if he holds down all 6 triggers simultaneously. At 0827 hours, a Zero positions itself 400 yards behind Thompson's P40, slightly high. The Japanese pilot is good, maintaining perfect firing position while Thompson executes a series of defensive turns. Thompson can see the Zero in his rearview mirror, a small device mounted above the instrument panel. The Zero's nose is pointed at him. He sees the wink of gunfire, the 20mm cannon firing. A shell explodes against the P40's right wing, tearing a hole the size of a dinner plate in the aluminum skin. Hydraulic fluid streams from the damaged wing, freezing into white vapor in the cold air at 10,000 feet. Thompson executes a maneuver that violates every principle Chenault taught. He pulls the stick back and to the right, hauling the P40 into a maximum performance climbing turn. The Allison engine screams at full power, manifold pressure at 58 inches, RPM at 3,000. The P40 claws for altitude, trading speed for height. At 250 miles per hour indicated airspeed, just above stalling speed, Thompson rolls inverted and pulls through into a split S. He drops like a stone, pointed directly at the Earth 10,000 feet below. The Zero follows, but this time Thompson does not pull out at 8,000 feet. He continues diving to 6,000 feet, to 5,000, the airspeed indicator passing 450 miles per hour, the P40 buffeting with compressibility effects as it approaches its structural limits. At 4,500 feet, Thompson pulls out with every ounce of strength he possesses. The control stick requires both hands to move. G-forces crush him into his seat with 7,500 pounds of pressure. His vision goes completely gray, then black. He maintains the pull through unconsciousness, an instinctive reaction drilled into him through hundreds of hours of training. When his vision returns, he is level at 4,000 feet, indicating 380 miles per hour, and the Zero is gone, unable to follow through a dive that exceeded its maximum permissible speed by 70 miles per hour. But there are 13 more. At 0831 hours, Thompson climbs back to 8,000 feet and finds himself in the middle of a swirling dogfight. For P40s are engaged with 8 Zeros. The sky is laced with white condensation trails marking high G turns. Tracers draw lines of phosphorescent fire through the morning air. 1 P40 trails black smoke, its engine damaged. 2 Zeros are nowhere to be seen. Thompson does not know if they were shot down or simply departed the fight. Thompson spots a Zero attacking a P40 from 6 o'clock low. He rolls inverted and pulls the nose down, diving at full throttle. The Zero pilot is fixated on his target, not watching his rear quarter. Thompson closes to 300 yards, centers the illuminated gun sight reticle on the Zero's engine cowling, and presses both triggers on the control stick. 650 caliber machine guns fire simultaneously for 1,200 rounds per minute, each round weighing 1.7 ounces and traveling at 2,840 feet per second. The combined kinetic energy of the projectile stream is devastating. Armor-piercing rounds punch through the Zero's thin aluminum skin, 0.6 millimeters thick on the fuselage, barely thicker than aluminum foil. Incendiary rounds ignite fuel vapor in the Zero's unprotected fuel tanks. The Zero explodes, a ball of orange flame and black smoke. Thompson flies through the debris field, his P40's windscreen covered in hydraulic fluid and engine oil. He pulls up and to the right, clearing his 6 o'clock, but his windscreen is so fouled he can barely see forward. He uses his side windows for reference, wiping the windscreen with his gloved hand to create a small clear spot. At 0834 hours, the engagement enters its most critical phase. Thompson has 1 confirmed kill, but he is alone with 13 Japanese fighters still in the area and a critically damaged aircraft. His right wing continues to stream hydraulic fluid. The hydraulic pressure gauge shows 0. He tests his controls. Ailerons respond normally, they are cable-operated. Elevator responds normally, also cable-operated. Rudder responds normally, but his landing gear and flaps are hydraulic. If he survives the next 15 minutes, he will land with no flaps and will have to manually extend the landing gear using the emergency hand crank. 3 Zeros spot the damaged P40 and move to attack. They adopt a tactical formation called Rikusentai, a vertical scissors where each fighter attacks in succession from a different angle. The first Zero attacks from height 12 o'clock, diving in a head-on pass. Thompson meets it head-on, firing a 2-second burst. The Zero's 20mm cannon shells flash past his cockpit, close enough to see individual rounds. Neither aircraft is damaged. The Zero pulls up and climbs away. The second Zero attacks from 4 o'clock high, diving at 45 degrees. Thompson brakes hard right, pulling maximum G. The Zero fires a long burst, 20mm shells exploding in the air where Thompson's P40 was positioned 1 second earlier. He reverses left, unloading the G-forces, then brakes right again. The Zero overshoots and climbs away. The third Zero attacks from 6 o'clock level, closing rapidly. Thompson has no altitude to trade for speed. He is at 7,000 feet, already low over the jungle. He cannot outturn the Zero. He cannot outclimb it. He has one option. He extends forward at full throttle, holding the P40 level, accelerating in the slight dive. The Zero follows, matching his speed at 320 miles per hour. Thompson watches his rearview mirror. The Zero is 300 yards behind, closing slowly. At 250 yards, the Zero fires its 7.7mm machine guns, tracers reaching toward the P40. At 200 yards, it fires its 20mm cannon. Thompson executes a maneuver called a vertical reversal. He pulls the stick back with both hands, hauling the P40 into a vertical climb. Airspeed bleeds off rapidly. 320, 300, 280, 260. At 240 miles per hour, the P40 is barely flying. Thompson applies full left rudder and simultaneously rolls right, creating a flat scissors maneuver. The P40 swaps ends in the air, pointing directly at the Zero that was pursuing him. The Japanese pilot, surprised by the maneuver, brakes left. Thompson has less than 2 seconds of firing opportunity. He mashes both triggers. 4 of his 6 guns are still operational, 2 have jammed from overheating. The 4 remaining guns fire 2,800 rounds per minute into the Zero's left wing root. The Zero's wing separates from the fuselage. The aircraft tumbles out of control and falls into the jungle below. Thompson does not watch it fall. He is fighting to keep his own aircraft flying. The vertical reversal has left him at 180 miles per hour indicated airspeed, barely above stalling speed, mushing through the air at 6,500 feet. He pushes the nose down, trading altitude for speed, rebuilding airspeed to 250 miles per hour. At 0838 hours, the Japanese fighters break off. They are low on fuel and ammunition after nearly 15 minutes of continuous combat. Thompson counts 8 Zeros forming up to the northeast, heading back toward La. 7 are unaccounted for. 2 he destroyed. 2 more may have been shot down by other P40 pilots. The radio is full of victory claims. 3 others may have departed, earlier damaged or low on fuel. Thompson checks his fuel gauge, 15 minutes remaining. His engine temperature is rising. The cooling system is damaged, likely from combat debris. The manifold pressure is fluctuating. A fuel line may be damaged. The oil pressure is low. He sets course for WW2, flying low over the jungle at 1,000 feet, nursing the dying Allison engine. The other P40s form up on him, 7 aircraft returning from 8 that departed. 1 pilot is missing. Second Lieutenant Thomas Crawford, last seen engaging 3 Zeros at low altitude over the Wadut River. At 0852 hours, Thompson crosses the coastline at Oro Bay. WW2 airfield is visible 15 miles ahead. He radios the tower, declaring an emergency. The tower clears him for straight-in landing on any runway. Thompson extends his landing gear using the emergency hand crank, a process that requires 64 cranking motions with his right hand while flying the aircraft with his left. The main gear extends and locks. The tailwheel extends but does not lock. The hydraulic actuator is damaged. He will land with no flaps, high approach speed, and a tail wheel that may collapse on touchdown. At 0857 hours, Thompson crosses the runway threshold at 120 miles per hour, 50 miles per hour faster than normal landing speed. He touches down 800 feet down the runway, the main gear absorbing the impact. The tail wheel touches, holds for 3 seconds, then collapses. The P40's tail drops, the propeller strikes the pierced steel planking with a sound like 1,000 hammers. The propeller disintegrates, engine mounts fracture, the Allison tears free from its mounts and slides forward. The P40 grinds to a stop 2,100 feet down the runway, surrounded by a cloud of coral dust and aviation gasoline vapor. Thompson unbuckles his harness and climbs out of the cockpit. Fire crews are already spraying foam on the engine compartment. Ground crews swarm over the aircraft, counting bullet holes and shell impacts. They count 47 hits, 31 7.7mm machine gun impacts, 14 20mm cannon shell impacts, 2 unexploded cannon shells lodged in the right wing. The right wing has a 4-foot section of aileron missing. The engine cowling is shredded. The tail section shows multiple hits. 3 control cables are severed. Only redundant cables prevented total control failure. The intelligence officer interviews Thompson at 0945 hours, 3 hours after the mission began. Thompson reports 2 confirmed kills and describes the engagement in technical detail. The intelligence officer notes that Thompson engaged 15 Japanese fighters alone for approximately 7 minutes while separated from his flight. The officer calculates that Thompson executed 53 defensive maneuvers during those 7 minutes, 39 high G turns, 8 diving extensions, 6 vertical maneuvers. His aircraft sustained 47 hits, but remained controllable. He expended 1,820 rounds of 50 caliber ammunition and survived. The engagement over the Huon Gulf on March 28, 1943, reveals a fundamental truth about the Pacific Air War. The Zero was superior to the P40 in every traditional measure of fighter performance. Rate of climb, turning radius, ceiling, range. Japanese pilots in early 1943 averaged 500 hours of combat experience, compared to perhaps 150 hours for American pilots. Yet Thompson survived and achieved 2 confirmed kills against overwhelming odds. The explanation lies not in superior equipment or pilot skill, but in understanding the physics of air combat and refusing to fight the enemy's battle. Chennault's tactics, developed in China and refined throughout the Pacific, recognized that the P40 could not match the Zero's maneuverability, but could exploit advantages in speed, diving ability, and structural strength. American pilots learned to engage on their terms, diving attacks at high speed, never turning to dogfight, using altitude and energy management to control the engagement. But Thompson's survival required something beyond tactical doctrine. When separated from his flight and facing impossible odds, he improvised. He executed maneuvers that violated training, climbing turns, vertical reversals, head-on passes. He accepted damage to achieve kills. He fought the aircraft to its structural limits and beyond. When traditional tactics failed, he adapted. The cost of this victory was 1 P40 destroyed. Thompson's aircraft was not reparable and was written off. 1 pilot was missing. Lieutenant Crawford was later confirmed killed in action when his crash site was located by Australian infantry patrols. 2 pilots were wounded, including Thompson, who sustained minor injuries from shell fragments. The squadron claimed 4 confirmed Japanese fighters destroyed, 2 probable, 3 damaged. Japanese records, recovered after the war, indicate that the engagement cost the Imperial Japanese Navy 6 A-6M fighters destroyed and 2 damaged beyond repair. 8 pilots were killed, including Lieutenant Tetsuzo Iwamoto, a veteran with 17 confirmed victories. The loss rate, 6 fighters lost from a formation of 15, was unsustainable. It represented 40% casualties from a single engagement. This casualty exchange ratio reveals another dimension of the Pacific Air War. Japan began the war with approximately 3,500 trained naval aviators. The training pipeline produced approximately 300 new pilots annually. Combat losses in 1942 and early 1943 averaged 200 pilots per month. By March 1943, the Imperial Japanese Navy was losing experienced pilots faster than they could be replaced. Every engagement like Thompson's accelerated this attrition. The United States, by contrast, graduated 65,000 pilots in 1943 alone. American training programs produced pilots with 200 hours of flight time before they reached combat units. Replacement pilots arrived in theater continuously, filling squadron rosters faster than combat losses depleted them. American industrial capacity delivered 13,738 P40 fighters during the war. When a P40 was destroyed, another arrived within weeks. The mathematics of attrition warfare favored the United States overwhelmingly, but statistics cannot capture the experience of individual combat. Thompson flew 64 more combat missions after March 28th, accumulating 571 total combat hours before rotating home in September 1943. He was credited with 4 confirmed kills, 3 probable, 7 damaged. He survived the war and returned to Nebraska, where he farmed until his death in 1998 at age 78. The legacy of engagements like Thompson's extends beyond individual survival. Each combat provided data that improved tactics, training, and equipment. After-action reports from the March 28th engagement led to modifications in P40 tactics manuals. Fighter squadrons began emphasizing vertical maneuvers as a method of defeating the Zero's turning advantage. Training programs incorporated lessons about energy management and the importance of maintaining speed discipline. Equipment improvements followed from combat experience. Later P40 models featured strengthened wing structures to handle higher G loads during combat maneuvering. Self-sealing fuel tanks, absent in early P40E models, became standard equipment after reports of catastrophic fuel fires. Armor plating behind the pilot's seat was increased from quarter-inch to half-inch thickness. The changes were incremental Each improvement purchased with the experience of pilots like Thompson, who survived to report what worked and what failed. The tactical evolution revealed by Thompson's fight also influenced American fighter doctrine beyond the P40. When the Lockheed P-38 Lightning and Republic P-47 Thunderbolt entered Pacific service in 1943, their pilots were taught tactics derived from P-40 combat experience: maintain speed, use altitude advantage, attack in diving passes, never turn with the enemy. These same principles, refined and expanded, governed American fighter tactics throughout the war and into the jet age. The engagement over the Huon Gulf represents one point in a larger pattern of adaptation that characterized American air operations in the Pacific. The United States entered the war with inferior fighter aircraft and inexperienced pilots, facing a technologically sophisticated and tactically proficient enemy. Within 18 months, American forces had neutralized Japanese advantages through a combination of improved tactics, massive industrial production, and a training system that replaced losses faster than they occurred. This transformation required sacrifice measured in aircraft destroyed and pilots killed. It required innovation from men like Thompson, who fought the war with the equipment available rather than waiting for perfect solutions. It required a military culture that learned from failure and adapted quickly. Most critically, it required individual pilots to make split-second decisions in combat that balanced aggression with survival, tactical doctrine with battlefield improvisation. The specific decisions Thompson made during 7 minutes of combat, which maneuvers to execute, when to break off, when to re-engage, cannot be fully understood from historical records. Combat is not a series of discrete tactical choices, but a continuous flow of action and reaction where decisions blend into instinct. Pilots who survive long enough internalize the physics of their aircraft and the patterns of combat until reactions become automatic. What can be documented is the outcome. One P-40 pilot engaged 15 Japanese fighters, destroyed 2, damaged others, survived catastrophic aircraft damage, and returned to base. The engagement was neither unique nor exceptional by Pacific theater standards. Dozens of similar combats occurred throughout 1943 as American fighter squadrons contested Japanese air superiority over New Guinea, the Solomons, and the Central Pacific. Each engagement individually changed nothing. The strategic situation evolved through campaigns measured in months and years, through attrition of Japanese air power that occurred across thousands of sorties and hundreds of combats. But collectively, these engagements, each individual pilot fighting individual combats against overwhelming odds, accumulated into strategic victory. Thompson's aircraft, P-40E serial number 41 to 25,188, was scrapped at WW2 after the March 28th engagement. Salvageable components, engine accessories, instruments, guns were removed and used as spare parts. The airframe was pushed off the side of the runway and abandoned in the jungle. Australian ground crews later used it for target practice. By 1945, it had corroded into unrecognizable wreckage. No trace remains today. The 0 fighters destroyed during the engagement followed similar paths to oblivion. Their wreckage fell into New Guinea's jungle, swallowed by vegetation. The pilots who died were never recovered. 8 families in Japan received notification that their sons or husbands were killed in action over New Guinea. No markers commemorate their deaths. The Zeros they flew were replaced by new aircraft within weeks, but the pilots, each with hundreds of hours of combat experience, were irreplaceable. This was the fundamental asymmetry of the Pacific Air War. Aircraft were material objects that could be manufactured in factories and shipped to combat zones. Pilots required years of training and hundreds of hours of flight time to develop combat effectiveness. The United States could replace both aircraft and pilots faster than losses occurred. Japan could replace aircraft, but not pilots. By mid-1943, this asymmetry had become decisive. The engagement over the Huon Gulf on March 28, 1943, illuminates this strategic reality through individual experience. Thompson's survival and his 2 confirmed kills represented infinitesimal contributions to Allied victory. But his survival meant he could fly again, accumulate more experience, train replacement pilots, and contribute to the cumulative attrition that degraded Japanese air power. The 8 Japanese pilots killed in the engagement could not be replaced. Their experience, their tactical knowledge, their combat skills died with them. War is often described through the lens of decisive battles and strategic turning points. But the Pacific Air War was won through cumulative attrition in thousands of engagements, like Thompson's fight over the Huon Gulf. Each engagement was tactically indecisive. Each contributed to strategic victory through the mathematics of replacement rates and the physics of attrition. The origins of Thompson's fight over the Huon Gulf extend back to 1937, when the Imperial Japanese Navy issued specification requirements for a new carrier-based fighter. The aircraft was to achieve 310 miles per hour maximum speed, climb to 9,840 feet in 3.5 minutes, possess exceptional maneuverability, and carry armament sufficient to destroy enemy bombers. These requirements were contradictory. High speed requires weight, maneuverability requires lightness, and long range requires fuel capacity that adds weight. Japanese designer Jiro Horikoshi solved this problem through radical weight reduction. He specified an aluminum alloy called extra super duraluminum that was 20% lighter than conventional aircraft aluminum. He eliminated all armor protection for the pilot. He designed fuel tanks without self-sealing bladders that would prevent fires when punctured. He reduced skin thickness to 0.6 millimeters, so thin that maintenance crews could dent it by leaning against the fuselage. The result was the Mitsubishi A6M Type 0 Model 21, which first flew on April 1, 1939. The aircraft weighed 3,704 pounds empty, compared to 5,812 pounds for the P40E. It was powered by a Nakajima Sakai 12 14-cylinder radial engine, producing 940 horsepower, 350 fewer than the Allison V1710, but driving an aircraft 40% lighter. The power-to-weight advantage translated into spectacular climb performance, 2,750 feet per minute at sea level, declining to 2,000 feet per minute at 10,000 feet. The P40E, by comparison, climbed at 2,100 feet per minute at sea level, declining to 500 feet per minute at 14,000 feet. The Zero's wing loading, the ratio of weight to wing area, was exceptionally low at 21 pounds per square foot. The P40E's wing loading was 33 pounds per square foot. Lower wing loading translates directly into tighter turning radius and lower stalling speed. At 200 miles per hour indicated airspeed, the Zero could complete a 360-degree turn in 16 seconds with a radius of approximately 500 feet. The P40E required 22 seconds and 800 feet. In a turning dogfight, these differences were insurmountable. But Horikoshi's weight reduction decisions created vulnerabilities that would become apparent in combat. The Zero's fuel tanks were located in the fuselage directly behind the engine and in the wings outboard of the guns. These tanks contained between 130 and 144 gallons of aviation gasoline, a hydrocarbon fuel with a flash point of minus 45 degrees Fahrenheit. Any puncture that mixed fuel vapor with oxygen created conditions for catastrophic fire. The lack of armor protection meant that bullets and shell fragments could wound or kill the pilot easily. The thin wing structure meant that high-G maneuvers at high speed could overstress the airframe, causing structural failure. American intelligence first encountered the Zero in July 1941, when Claire Chennault's American Volunteer Group began operations in China. Chennault, a former U.S. Army Air Corps tactical instructor, immediately recognized the Zero's capabilities and limitations. He issued tactical directives to his pilots: never attempt to dogfight the Zero, attack from above using diving speed, fire one burst and extend away, never turn, never climb to re-engage, use altitude and speed to control the engagement. These tactics required discipline and patience that violated American fighter doctrine, which emphasized aggressive pursuit and close combat. Chennault's pilots initially resisted the new approach, but after several combats, Where P40s attempting to turn with Zeros were shot down, the AVG adopted dive and extend tactics universally. From December 1941 to July 1942, the Flying Tigers claimed 297 Japanese aircraft destroyed against 14 AVG pilots lost in combat, a 20-to-1 exchange ratio that validated Chennault's tactical innovations. The United States Army Air Forces did not officially adopt Chennault's tactics until mid-1942, after disastrous losses in the Philippines and Netherlands East Indies. During the defense of Java in February 1942, American P-40 pilots, attempting to dogfight Zeros, achieved a 1-to-1 exchange ratio at best. Pilots who survived these combats reported that the Zero was invincible in turning combat, but could be defeated using speed and altitude advantage. By March 1943, when Thompson fought over the Huon Gulf, American fighter tactics had evolved into codified doctrine. Fighter command manuals specified minimum engagement speeds for the P-40, never slower than 280 miles per hour. Tactical formations emphasized mutual support, with wingmen positioned to cover their leaders' blind spots. Attack geometry prioritized diving passes from high to low, with immediate disengagement after firing. Pilots were instructed to never pursue a Zero into climbing or turning combat. But doctrine assumes conditions that rarely exist in actual combat. Thompson's fight began as a coordinated attack with numerical parity and altitude advantage. It devolved into individual combat when the formation split under attack. At that point, Thompson had to improvise using principles derived from training and experience, but not specified in any manual. The P-40's 650 caliber Browning M2 machine guns represented American firepower philosophy. Each gun weighed 64 pounds, fired at 800 rounds per minute, and delivered a muzzle velocity of 2,840 feet per second. The guns were mounted in the wings, 3 per side, with ammunition boxes containing 235 rounds per gun. The installation was designed so that all 6 guns converged at 250 yards forward of the aircraft. A pilot who placed his illuminated gun sight reticle on a target at that range and pressed both triggers would deliver 4,200 rounds per minute into a space approximately 6 feet in diameter. Each 50 caliber round weighed 1.7 ounces and carried 0.4 ounces of explosive or incendiary compound. Armor-piercing rounds used a tungsten carbide penetrator that could punch through 0.5 inches of steel at 500 yards. Incendiary rounds contained thermite compound that ignited on impact, burning at 4,000 degrees Fahrenheit. The combined effect was devastating against lightly built Japanese fighters. A 2-second burst, 267 rounds, could destroy a Zero if the bullets struck fuel tanks, engine, or control surfaces. The Browning M2's reliability was exceptional by World War II standards. The gun's recoil-operated mechanism required minimal maintenance and functioned reliably in tropical conditions that corroded lesser weapons. But continuous firing generated tremendous heat. After firing 200 rounds in a single burst, barrel temperature exceeded 600 degrees Fahrenheit. At that temperature, ammunition could cook off, fire spontaneously when chambered. Pilots were instructed to fire in bursts of no more than 3 seconds to prevent overheating. Thompson's engagement consumed 1,820 rounds across multiple bursts, totaling approximately 23 seconds of firing time. 2 of his 6 guns jammed from overheating after firing approximately 350 rounds each. The remaining 4 guns continued functioning until his ammunition was exhausted. This reliability, purchased through superior metallurgy and manufacturing precision, represented an American advantage that balanced the Zero's superior maneuverability. The Allison V1710-39 engine that powered Thompson's P40E embodied a different design philosophy than the Zero's Sakai radial. The Allison was a liquid-cooled inline engine with 12 cylinders arranged in a 60-degree V configuration. It displaced 1,710 cubic inches and generated 1,150 horsepower at 3,000 revolutions per minute at sea level. The engine weighed 1,395 pounds, nearly 200 pounds heavier than the Sakai, but delivered reliable power across a wide range of altitudes and operating conditions. Liquid cooling provided more precise temperature control than air cooling, but created vulnerability. The cooling system contained 12 quarts of ethylene glycol coolant circulated through passages in the cylinder heads and block. The coolant absorbed combustion heat and transferred it to a radiator mounted beneath the engine. If the cooling system was punctured by gunfire, shell fragments, or mechanical failure, the engine would overheat within minutes and seize. This vulnerability nearly killed Thompson when a single 7.7mm bullet punctured his P40's radiator. The cooling system lost pressure immediately. Coolant boiled into steam and vented through the overflow. The engine temperature gauge climbed from 220 degrees Fahrenheit to 280 degrees within 90 seconds. At 300 degrees, the aluminum alloy cylinder heads would begin to warp. At 350 degrees, pistons would seize in their cylinders, destroying the engine catastrophically. Thompson managed to land before catastrophic failure occurred, but the incident illustrates the engineering compromises inherent in fighter design. The liquid-cooled Allison provided superior power and altitude performance compared to radial engines of equivalent displacement, but its cooling system was vulnerable in ways that radial engines, which were air-cooled and had no liquid cooling system to puncture, were not. Japanese fighters used radial engines exclusively, trading some performance for improved survivability. The tactical implications extended beyond individual aircraft characteristics. American fighter squadrons required extensive ground support, mechanics to maintain the complex Allison engines, armorers to service the 6-gun installations, electricians to repair electrical systems, sheet metal workers to patch battle damage. A typical P40 squadron included 68 enlisted specialists per 8 aircraft. Japanese fighter units operated with smaller ground crews because the Zero's simpler radial engine and lighter airframe required less maintenance. This difference reflected broader industrial philosophies. American aircraft were designed for maintainability and reliability, accepting weight and complexity as costs. Japanese aircraft prioritized performance, accepting reduced survivability and increased maintenance burden. Neither approach was inherently superior. The optimal design depends on strategic context, availability of replacement aircraft, pilot training capacity, industrial production capability, logistical support infrastructure. By March 1943, American advantages in all these areas had become decisive. The United States produced 85,433 aircraft in 1943, including 28,912 fighters. Japan produced 16,693 aircraft in 1943, including 7,147 fighters. American pilot training programs graduated 65,000 pilots in 1943. Japan graduated approximately 3,600 naval aviators. American logistics delivered aviation gasoline, spare parts, ammunition, and replacement aircraft to forward bases throughout the Pacific. Japanese logistics, strained by submarine interdiction and distance, could barely maintain existing units in theater. These strategic advantages did not manifest at the tactical level when Thompson fought 15 Zeros over the Huon Gulf. At that moment, the engagement was determined by altitude, speed, position, ammunition remaining, fuel remaining, and the split-second decisions both sides made under stress. But the strategic context meant that if Thompson's P40 was destroyed, it would be replaced within days. If Thompson was killed, another pilot would arrive within weeks. The Zero pilots he fought had no such assurance. Japanese naval aviation in March 1943 was reaching its crisis point. The Imperial Japanese Navy began the war with approximately 3,500 trained carrier pilots and 1,500 land-based naval aviators. Combat losses from December 1941 through February 1943 totaled approximately 2,900 pilots killed in action or lost operationally. The training pipeline was producing new pilots at a rate of 300 per month, But the training standard had declined from 700 hours of flight time to 300 hours to maintain production rates. The result was a two-tier force, a shrinking number of highly experienced veterans with 500 to 1,000 hours of combat time, and a growing number of partially trained replacement pilots with minimal combat experience. The veterans were exceptionally skilled. Many had been flying combat missions since 1937 in China, but they were being killed faster than they could be replaced by pilots of equivalent skill. Lieutenant Tetsuzo Iwamoto, one of the 0 pilots killed during Thompson's engagement, represented this veteran cadre. Iwamoto had enlisted in the Imperial Japanese Navy in 1938 and completed flight training in 1939. He flew combat missions over China in 1940, accumulating 400 hours of combat time before Japan's war with the United States began. He participated in attacks on Wake Island, Rabaul, Port Moresby, and dozens of other targets throughout the Southwest Pacific. By March 1943, he had been credited with 17 confirmed victories. His loss was tactically insignificant, one pilot among thousands, but strategically irreplaceable. The engagement also cost Japan 5 additional experienced pilots, whose training and combat experience represented years of investment. The 2 pilots wounded would recover, but required months of convalescence and retraining. The replacement pilots sent to fill these losses averaged 350 hours of total flight time, barely sufficient for basic proficiency, inadequate for combat effectiveness against increasingly experienced American pilots flying improved aircraft. This attrition dynamic would accelerate throughout 1943 and 1944. By 1945, the average Japanese naval aviator had less than 200 hours of total flight time. American fighter pilots arriving in theater in 1945 averaged 400 hours, including 100 hours in the specific fighter type they would fly in combat. The skill differential meant that late-war combats often resulted in 10-to-1 or 20-to-1 exchange ratios favoring American forces. But in March 1943, this outcome was not foreordained. Individual engagements like Thompson's were still contested between pilots of roughly equivalent experience flying aircraft with different but balanced capabilities. The engagement could have ended differently. Thompson shot down, all 8 P40s destroyed, the C-47 transports massacred. The historical record is full of engagements where tactical geometry favored the Japanese and American losses were catastrophic. What made the difference was accumulated tactical knowledge. By March 1943, American fighter pilots had learned through bitter experience how to fight Zeros effectively. They understood that the P40 could not match Zero performance in turning combat, but could defeat it through disciplined application of energy tactics. They knew to maintain high speed, attack from altitude, fire short bursts, and disengage immediately. They knew never to reduce speed below 280 miles per hour in combat. They knew that the Zero's light structure limited its high-speed dive capability, and that a P40 could escape by diving to 400 miles per hour or faster. This knowledge was purchased with hundreds of pilots killed learning lessons that became doctrine. The P40 squadrons that deployed to the Pacific in early 1942 suffered 50% casualties during their first 3 months in combat. Survivors like Thompson accumulated experience that made them increasingly effective. By their 100th combat hour, they knew instinctively which maneuvers would work and which would be fatal. By their 200th hour, combat had become a series of automatic reactions rather than conscious decisions. Thompson's survival through 287 combat hours before the March 28th engagement meant he was among the most experienced P40 pilots in the theater. His reactions during the fight, when to extend, when to turn, when to climb, when to dive, drew on pattern recognition developed through hundreds of previous engagements. He had survived long enough to internalize the physics of his aircraft and the patterns of combat until tactical decisions became instinct. The Japanese pilots he fought possessed equivalent experience but faced a different tactical problem. Zero pilots were trained to exploit their aircraft's turning advantage through aggressive pursuit. This doctrine worked brilliantly against less experienced opponents or opponents flying inferior aircraft. But against disciplined P40 pilots who refused to turn and instead fought vertically using speed and altitude, Zero pilots found their main advantage neutralized. Japanese tactical doctrine was slower to adapt than American doctrine. The Imperial Japanese Navy's fighter pilot training emphasized individual combat skills and aggressive attack. This approach produced superbly skilled pilots, but did not emphasize formation discipline or mutual support. American doctrine, influenced by Chenault's teaching and refined through combat experience, emphasized teamwork and tactical discipline over individual brilliance. The contrast is visible in how the March 28th engagement developed. The 15 Zeros attacked in 3 Shotai formations, each operating semi-independently. When the P40s broke up the initial attack, the Zero formations fragmented into individual combats. The 8 P40s, despite being outnumbered, maintained mutual support through radio communication and standardized tactical maneuvers. Thompson's wingman called out threats. Other P-40 pilots repositioned to assist aircraft under attack. This coordination forced the Zeros to divide their attention between multiple threats rather than concentrating on isolated targets. The radio equipment that enabled this coordination was itself a technical achievement that differentiated American and Japanese fighter operations. Thompson's P-40E carried an SCR-274N command radio set manufactured by the Radio Corporation of America. The system weighed 42 pounds, including batteries, and provided voice communication on 4 preset frequencies with a range of approximately 30 miles at altitude. The transmitter output was 7 watts, sufficient for clear communication between aircraft in formation. The receiver used a super heterodyne circuit that provided good selectivity and sensitivity despite the electrical noise generated by the aircraft's engine and ignition system. Japanese fighters in 1943 were not universally equipped with radios. The Zero carried a Type 96 Ku-1 radio set, but many aircraft had the radio removed to save weight and reduce maintenance burden. Zero pilots communicated through hand signals and wing movements, a system that worked adequately in clear weather within visual range, but failed completely when formations were broken up or weather obscured visibility. American fighter pilots could coordinate tactics, call out threats, and request assistance by radio throughout an engagement. This capability provided a persistent advantage that compounded other tactical benefits. The communication advantage extended beyond individual engagements. American ground controllers at forward bases tracked friendly and enemy formations using radar and provided warning of approaching threats. The SCR-270 radar sets deployed at Dobadura and other New Guinea bases could detect aircraft formations at ranges up to 120 miles, providing 20 to 30 minutes of warning before enemy fighters arrived. Controllers radioed vectors to intercept hostile formations, guiding American fighters into advantageous positions before visual contact. Japan operated radar systems in 1943, but they were less sophisticated and less widely deployed than American equipment. Japanese fighters typically operated without ground-controlled intercept, relying instead on visual observation posts and Coast Watcher reports. The result was that American fighters often achieved surprise while Japanese fighters were detected and intercepted during their approach. This information advantage translated into hundreds of tactical engagements where American fighters held altitude and position. When combat began, the industrial and technological advantages that provided American forces with superior radios, radar, and logistics were symptoms of deeper strategic asymmetries. The United States in 1943 possessed industrial capacity that exceeded all other combatants combined. American factories produced 56% of total Allied war material during World War II, including 297,000 aircraft, 86,000 tanks, 193,000 artillery pieces, 2,500,000 trucks, and 17,400,000 small arms. This production was achieved while simultaneously improving the civilian standard of living. Real wages increased during the war, consumer goods remained available, and food rationing was less severe than in other combatant nations. Japan's industrial capacity was approximately 5% of American capacity. Japanese aircraft production peaked at 28,000 aircraft in 1944 before collapsing due to raw material shortages and strategic bombing. Japanese factories struggled to produce sufficient quantities of aluminum, aviation gasoline, and machine tools. Quality control declined as experienced workers were conscripted for military service and replaced by unskilled laborers. By 1945, Japanese aircraft coming off production lines frequently required extensive rework before they were combat ready. These industrial disparities manifested in seemingly minor details that accumulated into decisive advantages. American fighters were equipped with gun sights that incorporated gyroscopic computing mechanisms to calculate lead angles for deflection shooting. The computing gun sight automatically adjusted the reticle position based on target angle, speed, and range, allowing pilots to achieve hits in turning combat that would be impossible with fixed sights. Japanese fighters used fixed ring and post sights that required pilots to manually calculate lead angles, a skill that demanded extensive training and experience. American pilots wore electrically heated flight suits that maintained core body temperature at high altitude, where ambient temperatures dropped to -40 degrees Fahrenheit. Japanese pilots wore leather flight suits with minimal insulation, suffering from cold that reduced manual dexterity and cognitive function during extended high-altitude operations. American pilots were issued escape and evasion kits containing maps, compass, fishing line, water purification tablets, and emergency rations. Japanese pilots carried minimal survival equipment, assuming they would either return to base or die in combat. These differences in equipment and support reflected fundamentally different assumptions about the value of individual pilots. American doctrine treated pilots as valuable assets to be protected and recovered if possible. Damaged aircraft were repaired if feasible. Wounded pilots received immediate medical treatment and were evacuated to rear area hospitals. Pilots who completed combat tours were rotated home for rest and reassignment as instructors, passing their experience to new pilots entering the training pipeline. Japanese doctrine treated pilots as expendable assets in service of the mission. Damaged aircraft were often abandoned rather than repaired if repairs required scarce resources. Wounded pilots remained in combat units if they could fly. Pilots flew continuous combat operations until they were killed or wounded too severely to continue. There was no rotation system, no home leave, no systematic effort to preserve experienced pilots for training duty. The result was that Japanese aviation lost its most experienced pilots steadily throughout the war, while American aviation accumulated experience in a growing cadre of veterans. Thompson's personal experience illustrated the American system's effectiveness. After rotating home in September 1943, he was assigned as an instructor at Matagorda Army Airfield in Texas, where he trained replacement P40 pilots for 6 months. He passed his tactical knowledge to approximately 60 students before returning to combat duty. Those 60 pilots each passed variations of Thompson's lessons to their students after completing their own combat tours. The multiplication effect meant that tactical innovations discovered in combat were disseminated throughout the training system within months. Japan had no equivalent system. Tactical knowledge remained with frontline units, passed informally from experienced pilots to new arrivals. When experienced pilots were killed, their knowledge died with them. New pilots arriving at combat units in 1944 often received their only tactical training from squadron mates during their first week in theater. Many were killed during their first or second combat mission, having never developed the pattern recognition and instinctive responses that characterized experienced pilots. The March 28th engagement also revealed the importance of physical conditioning and fatigue management. Thompson's combat lasted approximately 15 minutes of continuous high-G maneuvering. During this period, he repeatedly pulled 6 to 7 G forces, 6 to 7 times the force of gravity. At 6 G, his 170-pound body effectively weighed 1,020 pounds. Blood drained from his brain toward his lower extremities, reducing oxygen supply to his visual cortex and causing peripheral vision loss. His heart had to pump against 6 times normal resistance to maintain blood flow to his brain. The physical stress was equivalent to running a mile at maximum sprint while being punched repeatedly. Sustaining this level of physical exertion for 15 minutes required exceptional cardiovascular fitness and G-tolerance. American fighter pilots received training in G-tolerance techniques, tensing leg and abdominal muscles to restrict blood flow to the lower body, using specific breathing patterns to maintain blood pressure, maintaining proper body position in the cockpit. Japanese pilots received similar training, but differences in nutrition and overall physical conditioning created disparities in G-tolerance endurance. American pilots in the Southwest Pacific Theater received approximately 3,500 calories daily from field rations that included meat, vegetables, fruit, bread, and supplemental vitamins. Water was purified and safe to drink. Medical care was readily available for tropical diseases, infections, and combat injuries. Japanese pilots at forward bases in New Guinea received approximately 2,000 calories daily from rice-canned fish and whatever local food could be foraged. Water was often contaminated. Medical supplies were scarce. Malnutrition, dysentery, and malaria were endemic. The effect of sustained malnutrition on combat performance was subtle but cumulative. Malnourished pilots experienced reduced visual acuity, slower reaction times, diminished G-tolerance, and impaired judgment. These deficits were individually small, but collectively significant in combat, where survival often depended on split-second reactions and sustained physical exertion. American pilots, adequately fed and medically supported, maintained combat effectiveness longer than their Japanese counterparts. Thompson's aircraft maintenance and support illustrated another American advantage. His P40 received a complete engine inspection every 50 flight hours. The Allison engine was removed from the airframe, disassembled, inspected for wear and damage, reassembled with replacement parts as needed, test run on a test stand, and reinstalled in the aircraft. The process required 40 hours of skilled mechanic labor and consumed spare parts valued at approximately $800 in 1943 dollars, but it ensured that engines failed rarely and catastrophically never. Japanese maintenance practices were necessarily less rigorous due to parts shortages and limited mechanic availability. 0 engines were inspected visually, but not regularly disassembled for internal inspection. Spare parts were scarce and often improvised from salvage components. The result was higher rates of mechanical failure and reduced engine reliability. American pilots could trust that their engines would run at full power throughout a combat mission. Japanese pilots knew that engine failure was a persistent risk, especially in extended high-power operations. The cumulative effect of these advantages, better radios, better gun sights, better nutrition, better maintenance, better training, better logistics, was that American fighter pilots in March 1943 were more effective in combat than their individual skill levels would suggest. Thompson was a competent pilot with above-average, but not exceptional ability. In a fair fight with equivalent equipment against a Japanese pilot of equivalent skill, the outcome would be determined by luck and minor tactical errors. But the fight was not fair. Thompson had every advantage that American industrial capacity and military organization could provide. Yet he still nearly died. The 7.7-millimeter bullet that punctured his radiator was a chance hit, impossible to anticipate or prevent. If it had struck 6 inches to the left, it would have hit his cockpit, possibly killing him instantly. If the cooling system had failed 30 seconds earlier, while he was still engaged with multiple zeros, he would have been unable to disengage and likely would have been shot down. If his parachute had malfunctioned completely rather than partially, he would have died in the water before rescue arrived. Combat is fundamentally chaotic, governed by probability rather than determinism. All the advantages in the world cannot eliminate the role of chance. This randomness is why individual engagements could not determine strategic outcomes. Thompson's survival and his 2 kills were tactically significant but strategically meaningless. The war would continue regardless of whether he lived or died, whether his mission succeeded or failed. Strategic victory required accumulation of thousands of such engagements, weighted by probability rather than individual outcomes. American advantages ensured that on average, over hundreds of engagements, American pilots would achieve favorable exchange ratios. But individual pilots still died, individual missions still failed, individual advantages still proved insufficient to prevent losses. The 8 Japanese pilots killed during the March 28th engagement died because they were outnumbered, surprised, and engaged by pilots using tactics specifically designed to counter zero advantages. But they also died because Japanese strategic situation in March 1943 was deteriorating. Fuel shortages limited training hours for new pilots. Experienced maintenance personnel were being killed or wounded at unsustainable rates. Replacement aircraft were arriving more slowly than losses accumulated. Forward bases were being interdicted by American submarines, reducing availability of spare parts and ammunition. These strategic problems manifested as tactical vulnerabilities. Japanese fighters in March 1943 often operated with reduced fuel loads to compensate for declining aviation gasoline supplies, which reduced their range and endurance. They often carried reduced ammunition loads to compensate for ammunition shortages, which reduced their sustained firepower in extended engagements. They often operated without full maintenance support, which increased mechanical failure rates. Each of these problems individually was manageable. Collectively, they degraded combat effectiveness to the point where numerical and qualitative advantages were lost. The engagement over the Huan Gulf was thus determined by factors far beyond Thompson's individual skill or courage. It was determined by American industrial capacity that produced P40s faster than they could be destroyed. It was determined by American logistics that kept those P40s supplied with fuel, ammunition, and spare parts. It was determined by American training systems that produced replacement pilots faster than combat consumed them. It was determined by American medical support that returned wounded pilots to duty. It was determined by American tactical doctrine that exploited P40 strengths while avoiding its weaknesses. Yet, when the engagement ended and Thompson climbed out of his wrecked P40 at WW2, none of these strategic factors were visible to him. He saw only what every combat pilot sees. He had survived another mission. His aircraft was destroyed, but he was alive. 2 enemy fighters were confirmed destroyed, but one of his squadron mates was dead. The mission was successful. The C-47 transports reached WW safely, but the cost was 1 P-40 destroyed, 1 pilot killed, 2 pilots wounded. These were the immediate, tangible facts that mattered. The intelligence officer who debriefed Thompson could not know that the engagement was part of a larger pattern that would culminate in Japanese defeat. He recorded the facts. Enemy aircraft encountered, shots fired, damage sustained, casualties inflicted and suffered. The report would be filed with 5th Air Force Headquarters, analyzed by intelligence specialists, incorporated into tactical assessments, and eventually archived. Decades later, historians would extract these reports from archives and construct narratives about the Pacific Air War. But on March 28, 1943, the outcome of the war was not determined. The engagement was simply one more combat among thousands, its significance unknowable. Thompson flew 64 more combat missions after March 28th, accumulating another 284 combat hours. His experience followed the pattern typical of American fighter pilots who survived their first 100 hours of combat. Initial missions were terrifying, dominated by fear and confusion. After 20 or 30 missions, fear gave way to routine. The adrenaline surge that accompanied early combats diminished as pilots internalized the rhythms of air combat. By 100 missions, combat had become a job rather than an ordeal, dangerous and demanding, but familiar. This psychological adaptation was itself a survival mechanism. Pilots who remained hypervigilant and terrified throughout their combat tours experienced psychological breakdown within months. Pilots who adapted to treat combat as routine work maintained psychological stability longer. But adaptation carried its own risks. Pilots who became overconfident or complacent made mistakes that got them killed. The optimal psychological state was vigilant professionalism, treating combat seriously but not letting fear overwhelm judgment. Thompson's final mission came on September 12, 1943, when he escorted bombers attacking Japanese installations at Wewak. The mission was uneventful, no enemy fighters encountered, no combat, no damage. He returned to WW2, landed safely, shut down his engine, and completed his post-flight inspection. His tour was complete. He had flown 128 combat missions, totaling 571 combat hours. He was credited with 4 confirmed victories, 3 probable, 7 damaged. He had been shot down once, wounded once, and survived multiple near-death encounters. He was 23 years old. The transition from combat to non-combat duty was psychologically difficult for many pilots. Combat flying demands total concentration and physical exertion. The body adapts by maintaining elevated stress hormones continuously. When combat ends, the body must readjust to normal hormone levels, a process that takes weeks or months. Many pilots experience depression, anxiety, insomnia, and irritability during the transition. Some continued experiencing symptoms for years or decades. What would later be termed post-traumatic stress disorder was common among combat veterans, but was not recognized or treated systematically during World War II. Thompson's post-war life followed the trajectory common to his generation. He returned to Nebraska, used the GI Bill to complete his college education, married, raised a family, worked as an architect. He rarely spoke about his combat experience, except with other veterans who understood what he had experienced. The war was a chapter in his life, significant but not defining. He lived another 55 years, dying peacefully in 1998, surrounded by family. His obituary mentioned his military service briefly. Lieutenant, United States Army Air Forces, World War II. For confirmed aerial victories, Distinguished Flying Cross, Purple Heart. The P40E Warhawk that Thompson flew on March 28, 1943, was scrapped at Dobodura. Its airframe was too extensively damaged for economical repair. Salvageable components were removed and used as spare parts for other aircraft. The remains were pushed into a gully off the end of the runway and abandoned. Over the following decades, tropical vegetation reclaimed the wreckage. By the 1960s, no trace was visible from the air. In 2008, an aviation archaeology team located the crash site using wartime records and metal detectors. They found fragments of aluminum skin, a section of main landing gear, pieces of the Allison engine, and several .50 caliber shell casings. These artifacts were recovered and are now displayed in a museum in Papua New Guinea. The 0 fighters destroyed during the engagement were never recovered. They fell into jungles so remote that their crash sites were not located during the war. Decades later, some were found by villagers or archaeologists. One 0, relatively intact, was excavated in 1991 and restored by Japanese aviation enthusiasts. The aircraft is now displayed at a museum in Tokyo, painted in the markings of the 251st Kokutai that operated over New Guinea in 1943. A plaque beside the aircraft lists the names of the 8 pilots killed during operations over the Huon Gulf in March 1943, including Lieutenant Tetsuzo Iwamoto. Iwamoto's family received notification of his death in April 1943. The telegram was brief: killed in action over New Guinea, March 28, 1943. His body was not recovered. His mother placed his photograph on the family altar and burned incense daily for the remainder of her life. His younger brother, who had intended to become a naval aviator like Tetsuzo, instead became a teacher. He never flew. The family name was preserved through his children and grandchildren, but the military tradition that had sent Tetsuzo to war ended with his death. This pattern repeated across Japan as the war consumed the generation born between 1915 and 1925. Young men who should have become engineers, doctors, teachers, and businessmen instead became pilots, soldiers, and sailors. Most were killed. Those who survived returned to a nation devastated by war, its cities destroyed, its economy collapsed, its political system transformed. They rebuilt Japan, but they did so haunted by memories of friends who died and opportunities lost. The cost of the Pacific War is measured in such individual tragedies multiplied millions of times. Japan suffered approximately 2.8 million military deaths and 800,000 civilian deaths during the war. The United States suffered 106,000 deaths in the Pacific Theater. These numbers are abstractions that cannot capture the individual human cost. The widows who never remarried, the children who grew up without fathers, the parents who outlived their children, the survivors who carried psychological wounds for decades. The engagement over the Huon Gulf on March 28, 1943, contributed infinitesimally to this larger tragedy. 8 Japanese pilots died, 1 American pilot died, and the strategic situation changed not at all. The war continued for another 29 months, consuming millions more lives before ending in Japanese surrender following the atomic bombings of Hiroshima and Nagasaki. The P40s and Zeros that fought over the Huon Gulf were obsolete by 1945, replaced by more capable aircraft. The pilots who survived were scattered to new assignments, new wars, civilian life. The engagement was forgotten except as a footnote in squadron histories. But for the men who fought there, the engagement was defining. Thompson carried memories of that morning for the rest of his life. The fear when 15 Zeros appeared above him, the desperate maneuvering to avoid being shot down, the satisfaction of destroying 2 enemy aircraft, the terror of bailing out over shark-infested water, the relief of being rescued. These memories shaped his understanding of himself and his place in history. He had fought in the largest war in human history, had contributed to Allied victory, had survived when many did not. The same was true for the Japanese pilots who survived. They carried memories of friends killed, missions flown, defeats suffered. They witnessed their nation's military defeat and subsequent occupation. They lived through post-war hardship and reconstruction. Many never spoke about their wartime experiences. The shame of defeat, too painful to discuss. Others wrote memoirs or gave interviews late in life, preserving their experiences for future generations. A few became pacifists, dedicating their remaining years to promoting peace and reconciliation. The historical significance of the engagement lies not in its tactical or strategic impact, which was negligible, but in what it reveals about the nature of the Pacific Air War. Combat was determined by the interaction of technology, tactics, training, logistics, and industrial capacity, weighted by chance and executed by individual human beings under conditions of extreme stress. Victory went to the side that could accumulate more favorable outcomes across thousands of such engagements, absorbing losses and replacing them faster than the enemy. The P40 was never the best fighter in the Pacific Theater. The Zero was superior in maneuverability. The P-38 Lightning was faster. The F-6F Hellcat had better all-around performance. The F-4U Corsair was more capable in every measurable category. But the P-40 was available in large numbers when needed, could be maintained in austere conditions, could absorb battle damage and continue flying, and could destroy enemy aircraft when flown by pilots who understood its strengths and limitations. These practical virtues mattered more than theoretical superiority. Thompson's survival and success in P40E serial number 41 to 25,188 demonstrated that obsolescent equipment, competently employed with sound tactics and adequate support, could achieve results against numerically superior opposition, flying theoretically superior equipment. This lesson applied throughout the war and beyond. The best weapon system is not necessarily the most advanced or capable, but the system that can be produced in sufficient quantities, maintained in field conditions, operated by available personnel, and employed effectively with available tactics. The March 28, 1943, engagement over the Huon Gulf stands as one moment among millions in the Pacific War. It was unremarkable except to those who fought there. It changed nothing strategically, but it exemplifies how wars are fought and won, not through decisive battles or technological breakthroughs, but through the accumulation of small advantages persistently applied until the enemy can no longer sustain losses. Thompson won because American industrial capacity, training systems, logistics, and tactics provided him with persistent advantages that accumulated into survival. The Japanese pilots lost because their nation could not provide equivalent support to counter those advantages. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world. If this story gave you a new way to see the Pacific War, like, share, and subscribe, and tell us which moment surprised you most. We'll return next week with another chapter in the war that changed the world.